So holes are places where the graph is not defined, but it's just like one section that's missing. So like if you had a line with a hole, it would look like that. And you'll see as we do this why that happens. So just like we did yesterday, we'll start with factoring. What do we have on the top? 2x and x. Negative 2 here and a negative 1 there. Does that work? 2x squared minus 4x minus 1x makes minus 5x plus 2. Are we good with that? Over x plus 2x minus 2 because they have the difference of perfect squares. So here is something that didn't happen yesterday, but is clearly going to happen now, which is what? The x minus 2 and x minus 2 factors cancel. So this function simplifies to x plus 2. But it's important to know that this original function and this simplified version of the function are not exactly the same, right? They're equal expressions for all values except for 2. Because if this was r of x and this was, I don't know, j of x, r of 2 would be undefined, but j of 2 would be defined. Do you see the difference? Every other number is going to work out exactly the same except for 2. So do you remember when you simplified rationals last year and you would like factor and cancel things? There were some excluded values. Like the original expression equaled the simplified expression for all values of x except, and you had excluded values. This is similar. These graphs will be exactly the same for all values of x except for 2. Really because r of 2 is undefined and j of 2 is 4 minus 1 is 3, 2 plus 2 is 4, 3/4. Everything else about these graphs is going to be identical. So the takeaway is we're going to use this one to do the graphing just because it's simpler. And the only difference is there's a hole at that location. Because we're technically graphing this one. We don't want to graph this one, even though they're going to look virtually identical. This one itself wouldn't have a hole. It would actually have a point at 2 3/4. But because we're graphing this one, there's going to be a hole there. So using this, what are your vertical asymptotes? Vertical asymptotes? X equals negative 2. Horizontal asymptote? Y equals 2. Same over same. So 2 over 1 is 2. So I'm going to get that started. My x-intercept. When will this numerator equal 0? It's when your numerator, 2x minus 1, equals 0. Which will be an x value of 1/2. So there's your x-intercept, which pretty much tells me that this is going to be cornered down here. And the other one's going to be cornered up over here opposite. The y-intercept, though, plug in 0. You get 2 times 0 minus 1 over 0 plus 2, which is going to be negative 1/2. That's your y-intercept. You want to label those, so this one was 1/2, this one was negative 1/2. And you can kind of connect those, understanding what that rational curvature looks like typically. And then just by default, I don't really care about accuracy of exact points. This is going to be up in that corner. The only problem is we just graphed j of x. And it's going to look exactly the same as r of x, except for in r of x, which is what we're supposed to be graphing, this should be undefined at 2. So at 1, 2, we need to put a hole there. And it does kind of work out. It should be at 2, 3/4. So, calculators are not going to show you holes. Sometimes it does, sometimes it doesn't. I think it has to do with the quality of, what's that? No, like calculators at the end of the day, these calculators anyway, are just computers, but it's like almost like a pixel issue. Like they don't have really good resolution, so you don't see, if you did it like on a really legit calculator, a really advanced one, you'd probably see it. So if I just graph this, you can see the vertical asymptote, you can see the horizontal asymptote, you can kind of see the x and y intercept, how small they are, but you don't see the hole. I know it's over here somewhere just because I did it. So if I want to zoom in, you guys ever use the zoom in feature? And then if I scroll over to 2-ish and up, I'll zoom in to whereabouts the hole is supposed to be. And sometimes you can see it and sometimes you can't. You really can't see it here. The reason I know it's going to be there is if I do second trace and I look for the value at an x of 2, normally the y coordinate would show up, but it's going to come up blank because there's nothing there. Does that make sense? If I do second trace value and I want to know the y coordinate when x is 1, it's going to tell me 1 1/3. But if I do it at the hole, it's just going to come up with like a blank spot. So you can confirm if you want that the hole is actually at the location of 2. Does that make sense? Okay. That's really the only extension, is that when things cancel, no, that's not a vertical asymptote anymore, that's a hole. Still a point of discontinuity. Asymptotes create a discontinuity. Do you know what I mean by that? Discontinuous? Like I can't continuously draw the graph. I have to pick up my pencil and start down here. Same thing when I'm tracing along a hole, I actually have to pick up my pencil and jump over that point and start on the other side. Okay. All right. Try the next one on your own without a calculator, start to finish, for good practice, so we can iron out what kind of issues you run into. Why? Because you have to do grouping on the denominator? Don't sweat it, Tommy. You're really good at grouping, I know it. Okay, so when you factored this, it went to x plus 2, rock. That at first, then you factored further and you got x plus 2, x minus 2, and x plus 3. So as soon as something cancels from the numerator and the denominator, you definitely have a hole. What x value used to be undefined and is now no longer going to be? -2. So your hole is at -2 something, because that's what canceled, and you figure out your something by plugging -2 into the equation that now will no longer be undefined. So -2 minus 2 is -4, so it's 1 over -4 times -2 plus 3 is 1. 1 over -4 times 1 is 1 over -4, so -1/4. That's where your hole is. Got it? You can do that then, or you can do it later. What's that?
That's your graph.
Yeah, I'm going to get there. So you don't get that?
I get it.
Okay.
I just don't know.
So, as far as graphing, go back to your main 4 features. Your vertical asymptotes, and we have 2 of them this time, are at 2 and -3. So there's a little bit more behavior that you're going to have to explore here because this creates like 6 different sections. Your horizontal asymptote, this is small over big. So at y equals 0. Your x-intercepts come from whatever's going to make your numerator 0. If your numerator is a constant number, then it will never equal 0, which means you will never have an x-intercept. Does not exist. And your y-intercept is just from plugging in an x of 0. So that will be 1 over negative 2 times positive 3, so negative 1/6. So here's where you just have, it's not something I can really document work for, so I'm going to explain to you the thought process. I've got my asymptotes on there. My y-intercept is at negative 1/6, so barely below the x-axis. So you have to figure out what the behavior is really in between the asymptotes. And we've seen sometimes it starts low, ends high. Sometimes it's like a parabola that flips upside down. Sometimes it starts high, ends low. Or sometimes it's a parabola that opens up. But pair this y-intercept with the fact that we have no x-intercepts, which means we cannot cross the x-axis. So there's no way this can go towards positive infinity as it approaches either of the asymptotes. When you go towards vertical asymptotes, you have to go positive infinity or negative infinity. We just can't go positive here because we're not allowed to cross the x-axis, right? Let's pretend you didn't put that together. Just plug in 1 and see if you get a positive or a negative, and see if it's higher or lower than negative 1/6, and it will be lower. So this has to go towards negative infinity because it can't cross the x-axis, and the same is true over here because we can't cross the x-axis. And then your behavior on the outside is going to be in either one of these quadrants, and basically talking about like the degree of the vertical asymptote. Each of our vertical asymptotes has a degree of 1. So if one side goes towards negative infinity, then the other side has to go towards positive infinity. And there's your little corner for the graph to finish off in, and it approaches the horizontal asymptote as you move towards infinity. And then this also has a degree of 1, so if this is going down, then on the other side it has to go up. And then we're also like creviced in that corner, approaching the horizontal asymptote in the negative direction. And then you just have to really put your hole like an open circle on the graph. So it should be in approximately the right spot. This will just fine tune the graph a little bit. Negative 2, negative 1/4 is like there. So I'm just going to redraw my graph so that it hits that hole.
You got a different hole?
Yes. You have to put an open hole at that location. So you actually graph this then. Where this graph and this graph look virtually identical with the exception of a hole. And sometimes you can have 2 holes. Like if 2 factors cancel, you'll have holes in 2 different spots. Does that make sense? Any questions? Yeah. The hole. So negative 2 is where the hole was. You know how to get that. If you plug negative 2 into the original, it's going to give you undefined because that point's not. But if you plug it into the simplified version, you'll get the y coordinate.